Howdy, Huskies. Mr. Otten here. We're going to go over the review. My review is just I needed a little bit more space rather than everything side to side, so I just moved it around, but it is the exact same that you have, so don't worry that things are in a different spot. The first thing I'll always say is jump around. Feel free to don't watch this entire thing. If you do, great. If not, no worries. So we're going to start with every time you see a C, that's going to be on the calc part. Remember, there's going to be a non-calc and a calc part, so be careful with that. So if you ever see a C, that's specifically calc. Everything else you should be able to do without a calculator. Alrighty, so we're going to start with 1 through 9. 1 through 9 is really just the basics, okay? And what we're really going to be looking for is just you guys writing all students take calculus, just applying that concept and your unit circle to where you have it, okay? So keep that in mind. The next thing I really want you to notice is that you have some different directions here. So on 1 through 5, they want just the answers. But then on 6, it's saying, hey, I want all the answers. So that's when we're going to use our K. So be careful because on your celebration, you're going to have to know which ones to put. Alrighty. So the first thing we're obviously going to do is you want to isolate your variable. And your variable is almost always going to be with your trig function. So you're going to isolate your variable, your trig function. And for 1 through 9, they're already all isolated. So check there. Step number 2, always draw your picture. And your picture should be all students take calculus, just as was mentioned. And then go to town. So on this first one, we know that all students take calculus. Since this is a positive, it will not exist on this side of our coordinate plane. So we can cross that off. So I need to know basically that I'm going to have 2 answers. So if it's in this first quadrant, we know from our unit circle that this is going to be pi over 3. So that's going to be one of our answers. So we'll go pi over 3. And then we know if it's going to be in this quadrant down hizzle, it's going to be 5 pi over 3. You good with that? So we have our 2 answers. And so since it's not asking for K, all we're going to do is we're going to write them like this and call it good. X equals bazinga. We're good to go. Not a whole lot there. Okay. If you want to write them individually, going X is equal to pi over 3 and X is equal to 5 pi over 3, that's fine too. Whatever you feel fits your fancy. Alrighty. So negative, so it's already isolated, so all students take calculus. So because it's negative, sign is going to be positive in those top 2 quadrants, so we know it's down below. So when is sign going to be a negative 1/2? So again, this is from our unit circle. We should be good to go on our unit circle, and we know that that's going to be at 7 pi over 6. That's one of them. And then the other one's going to be 11 pi over 6. So we have our 2 answers of X is equal to 7 pi over 6 and 11 pi over 6. Cruising right along. Here we have a tangent function. We're good to go. We're going to start it the same way. All students take calculus. So it's positive, so it's not going to be in this one or this one. So if it's going to be 1, we obviously know that that's going to be right here chilling at pi over 4. And then the same in this quadrant, it's going to be at 5 pi over 4. So that's why we have our 2 answers of pi over 4 and then 5 pi over 4. Cruising along. You guys are doing great. All right, this next one has got a 4C next to it, so it's going to be a calculator. I'm going to pause to make sure my calculator is ready to go for us. I have my calculator. I'm going to hit second and then mode and then, notice that I'm in radian mode and that's where I need to be. So we're good to go there. So let's get this one started. So 5 pi over 6, it's not on my unit circle, but I still need to know where this bad boy lives. So since it's positive, it's going to be in those right 2 quadrants, okay? So I'm not sure exactly where I'm at. So if I hypothetically just draw this, what I'm looking for is this angle right here, which I'm going to call X. Cool? So if that's X, we're going to say cosine -1 is 5 over 6. And that's what we're going to put into our calculator. So I hit second cosine, that's where the -1 comes up. And 5 divided by 6 is going to go ahead and give me 0.586. So that is this angle right here. So remember, we want that exact same reference angle. So if I want that same reference angle, that's going to exist down here, where this distance is going to be x. So if I think of this as 2 pi all the way around, then I need to be less than 2 pi to be in this area that I want right here for this x. So how much is that? It's going to be basically 2 pi minus this. So we'll go ahead and say that 2 times 3.14, which is pi, minus 0.586 is going to give me what's left over, and that's going to be 5.697. So here are my two answers. The first one, which is going to be on the first quadrant, and then the second quadrant. So while I'm here, I might as well talk about my little way that I like to try to make sure I know what I'm doing. Okay, so this is going to be 2 pi, and we also know it's 0, so it's 6.28. This is 3.14. Okay, now to find out these other ones, okay, obviously it's going to be 1.57. And then if I use my calculator, we can say this is 3 pi over 2. So what's that as a decimal? So 3 pi, that's not pi. Come on, pi. There we go. Divided by 2. So it's 4.71. So as I mentioned, it needs to be in this quadrant right here, quadrant 4. So what's quadrant 4's range for a decimal? It's greater than 4.71 and less than 6.28, and that's where this lives. If I were to say, okay, I need to be in this top one, that's right here, that needs to be in between 0 and 1.57, and boom shakalaka, there it is. Great way to check your work, especially with these decimals. Alrighty, so tangent is going to be root 3. So all students take calculus. My tangent is positive, so by quadrant 2 and quadrant 4. So we know that this is going to be chilling right here at pi over 3, and then also going to be in this quadrant as 4 pi over 3. So x is equal to pi over 3 and 4 pi over 3. Now, these are decimals too, but we're just going to leave them in terms of fractions to make our lives easier. Okie dokes. So on these next ones, notice we're going to use the k aspect. So this is where we need to do our mapping. And so we'll hit that at the end of every example. We didn't have to do any mapping because it didn't ask for it. So now we have to. Alrighty. So 0 is going to obviously take place on one of our axes. So 0, remember on our points, it goes cosine, sine. So if this is 1, 0, this would be negative 1, 0. This is going to be 0, 1. And this will be 0, negative 1. We want when our cosine is 0. So that's right here and right here. Chilling specifically at the points pi over 2 and down here at 3 pi over 2. So if they ask for our answers, though, it would be answers, but they want the mapping part. So I like to say is how many degrees does it take to get me from here to here? Now, if you want, you can call this 90 and this is 270, or we can keep it in terms of pi. So to get us there, it's 180 degrees, which we know as pi. If that is a true map, if I were to go backwards, it should be that same thing, which is 180, which is pi. So it does map. If we do our congruence from geometry, this arc and this arc are the same. So what we're going to do is you're going to take your first positive one. So our first positive one is that pi over 2. And then plus, and it's going to be our, it's always plus. Let me go that way. So it's plus, and then you're going to be your map amount. And we found out that that was going to be pi. And then always times k. So we'll put a k there, and boom shakalaka, there's our answer. We're good to go. Alrighty, let's look at our next one. So sine is going to be root 2 over 2. So all students take calculus. So again, this is positive. So it's going to be in the top 2 quadrants. So we happen to know that this is going to be pi over 4, and then 3 pi over 4. So we have our 2 numbers. Okay, so let's take a look for our mapping. If I go here to here, that's going to be 90 degrees because I went from 45 to 135. And then all the way around, that's definitely not 90 degrees. So there is no mapping that works for this one, okay? So on number 6, I could get there because they were both, as we can see, 180. Not so much on here because I go from 90 to 270. So clearly those aren't congruent. So we're going to take our first answer, which is pi over 4 and plus 2 pi k, and then 3 pi over 4 plus 2 pi k for our answer on that one. Alrighty. So, ladies and gentlemen, boys and girls, just want to make sure we are all gravy, checking my answers with the answer key on my screen. Don't want to make some silly mistakes here. Alrighty. So we have a negative root 3 over 2. So all students take calculus. So this is negative, so I don't want to be here, and I don't want to be here. So we're going to be chilling in this region and this region. So this is going to be 5 pi over 6, and this is going to be 7 pi over 6. Now, let's take a look and see if we can go ahead and get there. Alrighty? So if I go from here to here, 5 pi over 6 is 150 degrees. 7 pi over 6 is 210 degrees. So this is going to be 60. And then from here all the way around, that's going to be not 60, 300 degrees. So there's going to be no mapping. So 5 pi over 6 plus 2 pi k, and then 7 pi over 6 plus 2 pi k. Alrighty. Let's move on here to number 9. Number 9, we got a negative again. Check it out. Okay. So all students take calculus. So it's not going to be here, and it's not going to be here because that's where tangent is positive. So root 3 over 3 is going to handle here at 5 pi over 6. And then down here in this quadrant is going to be 11 pi over 6. So let's do our mapping. So from here to here is pi, or 180 degrees. Same thing on this side. So those are the same. So I'm going to take my first positive one, which is 5 pi over 6, and plus pi k, because my mapping amount was pi. Gravy? Easy peasy lemon squeezy? Cool. All right, so now let's get into a little bit more of the sauciness. And this is when we're actually going to be doing some solving. So here on number 10, all righty. So on this one, we can notice we have a cosine squared and a cosine. So the first thing that I want you to think of is when you have two terms, it's going to be one of two things. It's going to be a perfect square, or it's going to be a GCF. In both cases, though, we need to make sure it's equal to 0 for this to work. So since it's equal to 0, that's checked off. So since they both have a cosine, we're going to divide out by our cosine. So if I do this division, cosine divided by cosine is just going to be a cosine. And then this division over here, the cosines will cancel, and I'll just have a minus 3. So the GCF always has to go in front, so don't forget that. So I have cosine and then cosine minus 3, and that's equal to 0. So now we'll do them individually. So cosine of x is equal to 0, and cosine of x minus 3 is equal to 0. So let's start with just the first one since we got that. So cosine 0. So we'll go ahead and take a look. We know when our cosine is 0, that's right over here at pi over 2, and right here at 3 pi over 2. And since our directions are just find the answers, no mapping necessary. So let's just write them down. Pi over 2, 3 pi over 2. And then let's look over here. So I'm going to get cosine of x is equal to 3. Now, let's hold up again. This is a tricky one, so I'm glad that you're watching this video. So I'm going to say that cosine of x is equal to 3 over 1. Now remember, cosine is going to be adjacent over hypo. And in our lovely right triangle, your hypo is always the largest side. So if our hypo is 1 and our adjacent, which is right here, is 3, that doesn't satisfy a triangle. So in this case, we're going to call this undefined or no solution because it doesn't exist there. So that train of logic is done, is out the window, can't use it anymore. So we're just going to go back to the answers we have, and those are the only ones that are going to work for us. All right. On our next one, I have 1, 2, 3 terms. So if we go back up here, when I had 2 terms, we went ahead, we did a perfect square GCF. If it's 3 terms, we have 2 options. It's either going to be our x and then our factoring, if it factors, or God help us, negative b plus or minus b squared minus 4ac all over 2a. So we pray to the gods of factoring that we can factor and make this work. Alrighty. So we get a lot, sometimes we get so confused over the signs and everything. So I'm going to use u substitution. So u for this is going to be sine x. So since this is squared, it's going to be 2u squared minus a 1u minus 1. This I can factor. I think we all feel a little bit better factoring this. So I'll do 2 times a negative 1 to get my top number. So that's a negative 2. Add to a negative 1. And that's going to be 2 that's negative and 1 that's positive. So we're going to get 2u squared minus 2u plus 1u minus 1. Remember, we rewrite this. You just cancel out those middle terms and use those 2. So these 2 are going to be a 2u, and this is going to be a 1. So when we factor that out, I'm going to get 2u, and then u minus 1, and then 1, u minus 1. Our parentheses match. So I'm going to get 2u plus 1, and then I'm going to get u minus 1. So we're not done because they're set equal to 0. So 2u plus 1 is equal to 0. Moving on over. And then u minus 1 is equal to 0. So we get 2u is equal to negative 1. U is equal to 1. And then u is equal to negative 1/2. Well, we have our answers, and this would be great if it was a solving situation with just polynomials, but we are in our trig unit, so we got to remember that u is sine x, so we got to back substitute. So when is the sine of x 1, and when is the sine of x a negative 1/2? So we're going to tackle these individually. All right, so where is it 1/2? All righty, I made a goof there, and so I'm going to go ahead and I did an edit, and I just went back to where I found my goof. So every once in a while that happens. So it goes, all students take calculus. So it's negative, so it's not going to be in these 2 quadrants. Okay, so I'm going to be down here, and it's going to be 7 pi over 6. And then over here, it's going to be 11 pi over 6. Alrighty, so we have our 2 answers there, okay, because we know that that's where it equals a negative 1/2 because of our unit circle. And then we have the sine of 1. So when does it go cosine sine, and it's 0, 1? Well, that happens right here. Well, if this was a mapping problem, we would talk about that. But since it's not, we're just going to go ahead and say x is equal to pi over 2. And then our other ones, I like to put them in order. 7 pi over 6 and 11 pi over 6. Alrighty, so 12. 12 is a tough one, I'm not going to lie. I just saw that I goofed and I had to make sure we did this again. That's why you shouldn't do it at the end of the school day. But what I was going to mention, that if you do a perfect square and get cosine minus sine and then cosine plus sine, doesn't really help you. So sometimes we got to look at those identities and remember that this is the same thing as cosine 2x. Oh, I get it. Makes sense. So now we're going to use our delta substitution where delta is equal to 2x. So when is the cosine of delta equal to 0? And so obviously that's going to happen right here and right here. So that's pi over 2 and 3 pi over 2. If we do our mapping, pew, that's pi, pew. This one right here is going to be pi as well. So, ladies and gentlemen, boys and girls, this is going to go ahead and give me, we start with my easy one, so x is equal to pi over 2 plus, I should say, delta, pi k. And then we got to back substitute. So we're going to say, well, that's 2x is equal to pi over 2 plus pi k. So if we divide everything on both sides by 2, that's going to make this pi over 4 plus pi halves k. Now, if they were looking for all solutions, we were done, but they got us. They're asking for specific numbers. Lord have mercy. So obviously, we're going to write down one of our answers as pi over 4. So what's the next one? Okay, so I'm going to make this a common denominator. So if this is 4, I need a 2 over 2. So I'm going to get 1 pi over 4 plus 4 pi over 4. Excuse me, 2 pi over 4. And then that's going to go ahead and give me 3 pi over 4. So that's another one of our answers. So then 3 pi over 4 plus 2 pi over 4 is going to be 5 pi over 4. Okay, got another answer. We're good. 5 pi over 4. And then we're going to do it one more time. 5 pi over 4 plus 2 pi over 4, and that's going to be 7 pi over 4. Cool. There's your answers. Now, there is another way to do this, so I'm going to erase all this, and just because this is an optional video, I can take the liberties of doing this. And so another way to do this is to go ahead and use our Pythagorean identities. So remember that cos squared plus sine squared is equal to 1. So if I wanted to, say, make everything a cosine squared, I could rewrite this as 1 minus cosine squared is equal to sine squared. So cosine squared minus 1 minus cosine squared. If I distribute this negative, I'm going to get cosine squared minus 1 plus cosine squared. And since these are like terms, I'm going to get 2 cosine squared minus 1 is equal to 0. Move the 1 over. 2 cosine squared is equal to 1. Divide both sides by 2. And I'm going to go ahead and get cosine squared is equal to 1/2. Well, that's great, but I just want cosine. So square root, and I'm going to go ahead and get cosine is equal to 1 over root 2. Remember, we can't have that. So we'll rationalize and get root 2 over 2. Now, because we square rooted and we know that we have a unit circle, so it's all students take calculus, we need to have the positive and the negative. Because remember, if you take the square root of 4, it's 2 and 2, but negative 2 and negative 2 work as well. So that's why you say plus or minus 2, especially if you're solving for it, right? So same thing here. We have to have a plus or minus root 2. So if I start with a plus root 2 over 2, and then I also have a minus root 2 over 2, when I look at this, that's going to be basically every time in all of our quadrants when it's going to be pi over 4, 3 pi over 4, 5 pi over 4, and 7 pi over 4. So in this case, you could have had multiple ways to solve it, and I just wanted to show out both of them because I get to. Alrighty, moving on to number 13. Now we got a calculator one, so we're ready. So here I'm going to GCF it because I got 2 terms. So let's take out a tan x. So I'm going to get tan x. And then I should also take out a 2 to be honest with you. So I'm going to put that in front. So then we go ahead and have tan minus 2. So we'll set this equal to 0. So 2 tan x is equal to 0. And tan of x minus 2 is equal to 0. So this is just going to be tan of x is 0. Okay. And we happen to know that that is 0 and pi. And then over here, we're going to say when is tan of x equal to 2. That we're not so sure of. So we'll hit second tangent 2. And so we're going to get 1.107 for my x. So I have my x's here. So let's go ahead and make sure I have them all. So I know that I'm good here because that's one of our unit circles, but this one not so much. So let's make sure we got this all set up. So all students take calculus. We're going to be in, we're not going to be there, we're not going to be there. So we're going to go ahead and take a look at this and say, all right, I'm not sure where this is, but I know from here to here it's got to be 1.107. So I need to have that same thing down here. So how do we find that piece? Okay, well, if this is 3.14 AK pi, I'm going to add the 1.107 to find out what that x is as well. So that x is going to go ahead and give me 4.249. And thankfully, it's not talking about any mapping, so we're good to go. Sometimes it helps us out when we know what the directions are. Alrighty, last but not least here, 14. Before we go ahead and we mosey on over, or are we on the next page already? Nope, almost. So 2x, which means we're going to use our delta substitution. So delta is equal to 2x. So when is the cosine of delta root 2 over 2? So all students take calculus. We are going to go ahead and say, look at this. We are going to be positive, and so we're in those two quadrants. So we know that root 2 over 2 is going to be pi over 4. And then down here at 7 pi over 4, because that's our fancy schmancy unit circle. So let's do our mapping. So from here to here, 90, 270. So they're going to be unique. So x is going to be pi over, I should say delta, use my correct. So pi over 4 plus 2 pi k. And then we'll have delta is equal to 7 pi over 4 plus 2 pi k. Alrighty. Well, unfortunately, it is delta. It is not x. So we're going to say, by delta, you're a 2x. By delta, you're a 2x. And we're going to divide everything by 2. So I'm going to get x is equal to pi over 8 plus pi k. And then over here, we're going to get x is equal to 7 pi over 8 plus pi k. Alrighty, so we're finding all the solutions, so we're not done yet. We got to keep on rolling to make sure we are all set to go, okay? It's all right, it's had to step away, but I'm back. So I now know how my two answers, I'm going to write them off to the side here. They're not in order yet. I'm a fan of putting them in order, but let's just start with this first one right here. So I'm going to make this, since it's over 1, a common denominator, so 8 over 8. So I got 1 pi over 8 plus 8 pi over 8. And when I add those together, I'm going to get 9 pi over 8. So that's another answer, because we got to just make sure that it's over, less than 2 pi. So if I do 9 pi over 8 plus another 8 pi over 8, these should be consistent on whatever that common denominator is, and then you just keep adding to it. Now this is 17 pi over 8. So 8 goes into 17 twice with a remainder, so this is too much. So we're going to cross out that solution, and so I just have these two right here. Now we'll do the same thing, so on the other side, so this is over 1, so 8 over 8. So 7 pi over 8 plus 8 pi over 8 is going to give me 15 pi over 8. And clearly, if I add any more than that, I'm going to get too many. So I'm a huge fan of writing them in order. You don't have to, but it really helps us math teachers out. So pi over 8, 7 pi over 8, 9 pi over 8, and 15 pi over 8. Sometimes kids will be like, hey, can I just put like all those over 8, like pi, 7, 9, 15, all over 8? Don't be lazy. Don't be lazy. You can do this. Alrighty. So, ladies and gentlemen, we got a couple more here. We are cruising along. We are in double angle land. I want to make sure that I did all these right. Yep. Okay, we're moving on here, making sure we're good. So I'm going to make this because it's a double angle delta. So sine delta is equal to negative 1/2, where my delta is a 2x. I'm a fan of writing what delta is. So when is sine going to be a negative 1/2? Well, let's investigate. All students take calculus. So it's not in the top because it's negative. So 1/2 right here would be 7 pi over 6 and 11 pi over 6. And those look like good answers. And since we don't care about k's, we're good to go. So I'm going to go ahead and be 7 pi over 6 plus 2 pi k and 11 pi over 6 plus 2 pi k. And I'm going to say that that's what my delta equals, except remember it's delta. And that's why I like rewriting that I'm with delta, because then that's going to remind me, hey, you need to make this a 2x. So let's divide everything by 2. So in this top one here, we're going to get 7 pi over 12 plus, that's not a 12, there we go, plus a pi k. And then over here, we're going to get 11 pi over 12 plus a pi k. So, ladies and gentlemen, boys and girls, we are good to go, but we got to continue on to find our other solutions. So, let's go ahead and do common denominator. So I'm going to write down here 7 pi over 12, 11 pi over 12. So if I make this over 1, we'll go 12 and 12. Same thing down here, 12 and 12. So we're going to get 7 pi over 12 plus 12 pi over 12, and that's going to be too many pies. 19 pi over 12. Okay, so that's an answer. Let's write that down. 19 pi over 12, and then same thing here. So 11 pi over 12 plus 12 pi over 12. And so that's going to go ahead and give me 23 pi over 12. And we can clearly see that if we do one more, we're going to be way too much. So I'm going to stop right there. Okie dokes. So our next one is a triple. Alrighty. So here my delta is going to be equal to a 3x. So we'll say tangent of delta is equal to 1. So we happen to know, if we go all students take calculus, that since it's a positive 1, that's going to happen right here. So that's at pi over 4. And also down here at 5 pi over 4. So we can see that our period here is pi because that's tangent. So really this is going to be pi over 4 plus pi k, and that's what our delta equals. Oh boy, not x. So we got to substitute that back in, 3x, which means divide everything by 3. So x is going to be pi over 12 plus pi over 3k. Well, we don't have our solutions yet. So common denominator time, so it's like that k goes bye-bye. And we say this is a 12, so common denominator 4 over 4. So we're going to do 1 pi over 12 plus 4 pi over 12. And we're going to keep on going, because if we look at this, our denominator is 24, so this needs to be less than 20. Sorry, the bottom number is 12. It's got to be less than 24. Now, on this one, when we keep adding, there is going to be some reducing, so just as a heads up. So when I add, this is going to be 5 pi over 12. Then I'm going to add 4 pi over 12, and that's going to give me 9 pi over 12, and we know that that reduces to 3 pi over 4. So we have some answers here. Now, I'm going to keep this answer, but I'm going to use this and go 9 pi over 12 plus pi over 4. Sorry, 4 pi over 12, and that's going to be 13 pi over 12. No reducing necessary. So then we'll do 13 pi over 12 plus 4 pi over 12. And that's going to give me 17 pi over 12. No reducing. So all these are answers. Okay, and then we have obviously our 2 answers from right here. We can't forget those. Alrighty, so then we have 17 pi over 12 plus 4 pi over 12, and that's going to be 21 pi divided by 12, and that can reduce, so that's going to reduce to 7 pi over 4. So that's an answer. And then that's going to be our last one. So if we circle, we have 1, 2, 3, 4, 5, 6. So let's write them in order. Pi over 4, 5 pi over 4. I should say I need my 3 pi in there first. 3 pi over 4, 5 pi over 4. And then we have 13 pi. That's not in order, but you guys get the idea. Let's be good mathematicians here if I ask you to do something. So pi over 4, pi over 12. That's another reason why I screwed this up. So pi over 12, because of boom, that's pi over 12. And then 5 pi over 12. Goodness gracious, I almost wrote all the wrong answers. Good thing I decided to put them back in order. So now I have 3 pi over 4, then 17 pi over 12, and then we're going to have, I forgot my 13. Lord have mercy. Good thing you're only watching this if you need help. 7 pi over 4. There's our answers. Alrighty, so lots of answers, lots of good stuff. We're going to keep on cruising. Alrighty. So on this one, we're going to use our u substitution. So u is going to be our cosine x. So u squared plus 1u, got my 2 in front, minus 1. So let's factor this. So what two numbers multiply to a negative 2 and add to 1? Those are going to be 2 and negative 1. So 2u squared plus 2u minus 1u minus 1. Starting to go a little bit faster on these factorings. Hopefully you guys are doing okay with this. So this is going to be 2u minus 1. And then u, let's see, plus 1. And so when we set those equal to 0, 2u minus 1 is equal to 0. So u is going to be 1/2. And then we're going to get u plus 1 is equal to 0. So u is equal to negative 1. And then back substituting it in, when is my cosine 1/2? And when is my cosine a negative 1? So we back substituted, we got our spots, so now we're good to go. So the 1/2, all students take calculus. We're going to go ahead and be in this first quadrant and the last quadrant. So this right here is going to be pi over 3. And this will be 5 pi over 3. Alrighty, looking good there. And then negative 1, cosine of negative 1 is going to be chilling actually right there. So that's at pi over 2. So, ladies and gentlemen, boys and girls, we take the look at this as we got some mapping, since that's what our directions tell us to do, map. So how do I go from 60 to 180 essentially to pi? That's 120 degrees. This is another 120 degrees. And then this right here is another 120 degrees. Boom, we have some mapping that happens here. So pi over 3 plus 2 pi over 3k. Because that 2 pi over 3 is actually 120 degrees in radians. So that's why it's going to look the way it does. Alrighty, so I'm going to erase this because I clearly need some space here. So when I bring this over, I'm going to get sine squared x minus sine x. So I'm going to take out a GCF, that's a sine. So we'll get sine, and then sine minus 1 is equal to 0. So we get sine is equal to 0, and then sine minus 1 is equal to 0. So we'll get sine is equal to 1, and sine again equals to 0. So we got a lot of good stuff happen here. So if we take a look, remember it goes cosine, sine. So if I look here, this is 0, 1, okay? So I need that, so that's one of my spots. Then this is going to be, I did that backwards, excuse me. 1, 0, so I hit my spot there. Then here, this is going to be 1, 0, good there. Right here, this would be negative 1, 0. Again, good there. Keep good there. But then down here, we're at 0, negative 1. So that's not going to work. So here's our spots. So let's take a look. So I can go here to here, that's 90, here to here, that's 90, and then here to here, that's 180. Mapping is an issue on this one. So what we could say is, hey, well, what if we discount this top one? Well, if we do so, then from here to here is 180, and then here to here is 180. So I'm going to get 0 plus pi k, and that's going to work on this one and this one. And then the one we skipped over, which is up there at the top, we're going to do pi over 2 plus 2 pi k. And that's going to give me my values for that bad boy right there. Alrighty. And then 19 here, we got a perfect square action. So we're going to do cosine minus 1, cosine plus 1. So we're going to say, all right, when is our cosine equal to 1? And when is our cosine equal to negative 1? As we can see, because again, it goes cosine, sine, that those two values are going to be right here at 0 or 2 pi, and then right here at pi. So how do we go do our mapping? Here to here, that's pi. Here to here, that's going to be another pi. So we'll take our smallest number, which is 0, and go 0. That's not what I meant to do. Come on now. 0 plus pi k. Alrighty. Boom shakalaka. Making some great progress here, my friends. We got 2 more. So on this one, we're going to have to use the quadratic formula. I believe, is this? Nope, this one is not the quadratic formula. It is Saucy Town, though. The bonus is the quadratic formula. So for this one, we're going to say u is equal to tan x. So I'm going to go 2u minus 5u minus 3. Let's factor this. So what numbers multiply to a negative 6 and add to a negative 5? And that's going to go ahead and become negative 6 and negative 1. So 2u squared minus 6u minus 1u minus 3. So that's a negative 1. 2u. So we get 2u minus 1. And then u minus 3. Looking good so far. Loving it. Oops, sorry. I want to make sure I'm still recording here. Oh, it says I'm still recording. So life is good. Alrighty. So this was supposed to be a positive, and this was supposed to be a positive, and this was a positive. So this needs to be a positive right here. Sorry, my signs got all jumbled. So what happens when you've been videotaping for what, an hour at this point? We're cruising. All right, so now we got 2u plus uno is equal to 0, and u minus 3 is equal to 0. So u is equal to 3, and then 2u is equal to negative 1, so u is going to be a negative 1/2. All right, and then we plug our tangents back in. So when is tangent? A negative 1/2. And when is tangent going to be 3? That's our questions here. So let's go ahead and tackle this 1/2, because our answer key talks about an answer that we're not going to get when we plug it in our calculator. So all students take calculus. It's a negative, so it's going to be not in this quadrant nor this quadrant. So I'm looking for this x as well as this x right here. You with me? So right here, this is what we're going to get when we plug it in our calculator. So second tangent of negative 1 divided by 2, and that's going to be negative 0.4, what did I say, 64? Is that about right? Yep, close enough. So that's going to be the same as this angle right here, but I need to take pi and then take this away. So to find what this one is right here, I'm going to get x is equal to 3.14 plus essentially the negative 0.464. And the reason why we're doing a plus here is that because of the negative, it's going to back up. Because remember, this is 3.14 and this is 1.57. If I want to be in this quadrant, my decimal needs to reflect that relationship. So that x is going to be 2.678. Okay. Now, if you want to go ahead and go all the way around to find out what this one is too, so that's going to be 2 pi minus the, or so I say plus the point negative 0.464, which is going to give me 5.819. But since it's saying I want all values of k, I got to start with the smallest one, which is why I truly just needed this one. Okay? So I don't know why I put my k like that. That's kind of silly. So it's plus pi k. So that's one answer. So that is for this part right here. So let's do the 3 and call it good. So in the 3, all students take calculus. We're going to be in the first and the third. So I need to know this x right here. So let's go ahead and find what that is. So second tangent 3. So x is going to be 1.249. Or I should say it's going to be, it says 2 decimal places, so I should probably follow that. But you get the gist. So that is going to be the same as this one down here. So this x would be pi plus that 1.249. But since we want our values of k, and then this right here is going to be the smallest one, we're going to say it's just plus pi k. Alrighty, last one, the final countdown. Get your quadratic formula ready. So u is equal to sine x. So I got u squared minus 3u plus 1. Now I mentioned it's not going to factor because the numbers that multiply to 1 and add to negative 3 don't exist. There's no factors. So this is our a, b, and c. So x is equal to, or I should say in this case, u is equal to negative b plus or minus b squared minus 4ac all over 2a. So my negative 3 is going to go here and here. My 1 is going to go here and here. And then my lonely little c is going to go right there. So negative of negative 3 plus or minus negative 3 squared minus 4 times 1 times 1 all over 2 times 1. So this plus or minus means I'm going to have 2 answers when I'm all said and done. Alrighty, so 3 plus or minus 9 minus 4 divided by 2 is going to give me 3 plus or minus root 5 divided by 2. So 1 with a plus and 1 with a minus. So putting these in your calculator, I get 2.618, and then here I get 0.381. It's always nice to know you got to this far doing it right. All right, so remember this is what u equals. So u in this case is sine. So sine of x is equal to 2.618. And then sine of x is equal to 0.381. So danger, Will Robinson, we have an alarm going off on this one right here. Because remember, it's opposite over hypo. Your hypo has to be the longest side. Because really this is over 1, so this is opposite, almost wrote adjacent. Over hypo, this is not going to work. So this is undefined. It blows up, doesn't work. Good news, we have a little bit less work to do. So, all students take calculus. We are going to be in those top 2 quadrants. So right here, let's find out what this angle x is going to be. So, second sine of 0.381 is going to be 39. So this will be 0.391, we'll say. And so I need to have that same in this quadrant. So it's like almost, I'm going to have a different color here. I'm going to go all the way to here. So it's not quite pi, but it's definitely more than 1.57. You with me? So what we're going to do is we're going to go ahead and, give me just a second, sports fans. We're going to do 3.14 minus 1.57. And if we put that in the calculator, we get 2.67. And clearly those don't match on top of each other. So I'm going to get 0.391 plus 2 pi k. And then I'm going to get 2.67 plus 2 pi k. And those are your answers. It's been a pleasure. Oh, Lordy. Long video.